All right, team. This is a lesson where we are leveling up. So notice, here's an example problem that we'll get to in a second. Complicated these in several ways. So we have now 5 pi over 3. So no longer just 30, 45, or 60 degree angles. But this is, by the way, a multiple of one of those, right? Just like we've seen before in degrees. And then we have a cosecant instead of just sine, cosine, or tangent. So you're back to having to remember what those are. So what we're going to do here, believe it or not, first of all, you know all of the steps that you would have to take to find this one, right? So what I could do is I could convert this to degrees, draw it on the coordinate plane in my 4 quadrants, figure out this which of my 3 special angles is the reference angle, figure out the sines of each side, and so on and so forth. And then do cosecant, which is 1 over sine, so hypotenuse over opposite. That's a lot, right? That's a lot of different steps. It's a lot of opportunities to make mistakes. So we're going to introduce a reference here that we can use to make our lives much easier. It is called the unit circle. You will probably want, if you're working on your computer, you will probably want to Google a unit circle and bookmark it so you have it for a reference. If you're lucky enough to have a printer at home when you're working from home, I would print one off and have it for a reference. It's that useful. If you're in the building this spring, ask me and I'll print you one, okay, to use. Here is what it looks like. And it is easier than it looks. It's looking pretty complicated right now, I'm sure. If you're a big notes person, if you enjoy taking notes, feel free to make this in your notebook. Just make sure you copy it down accurately. But it is kind of a lot to copy down. I would find that personally like really tedious to copy all this down. So if you'd rather me print you one, let me know. So what this is it's basically this, right? So when you were first learning how to multiply, you didn't necessarily want to count by 12s all the way up to like 96 every time you had to know what 8 times 12 is. So you use this reference to look it up, and eventually, hopefully, you didn't need it anymore. This is a big one. You probably don't know what like 15 times 17 is off the top of your head. But most of these facts down here, at least, you now have memorized. This unit circle is the same idea, but for sine, cosine, and tangent of angles and radians. So what we're going to do is we're going to find 5 pi over 3 in the table. And these come in both degrees and radians, so make sure you find one in radians if you're looking one up online. Here it is. And this gives you the values of all sine, cosine, and tangent here in the table. Okay, so 5 pi over 3 is the coordinate 1/2 negative 3/2. You're like, well, what does that mean? Well, that's this point on the circle. What you need to know is sine is the y value, cosine is the x value. And there is a reason for that. I don't need you to know it, but if you're curious, let me know. It has to do with how this circle is built. So if we remember that what we want is 1 over sine 5 pi over 3, because that's the definition of cosecant, then we want to find sine, so sine is the y value. This becomes 1 over negative root 3 over 2. And then we just take the reciprocal, because that's what doing 1 over something does, right? 1 over fraction gives you its reciprocal. So negative 2 square root over square root 3 is what I get. And then I'll rationalize, right? So I'll do negative 2 square root 3 over 3. Okay, so that's how you use this reference. If I had wanted cosine, I would use 1/2 instead. So this tells me that cosine 5 pi over 3 is 1/2. So that's how you use it for sine and cosine. We'll do one more example, and then we'll talk about tangent. Okay, here's another example. So we want secant of 5 pi over 6. Secant is 1 over cosine, it's reciprocal of cosine, so I'll do 1 over cosine 5 pi over 6. And then I'll look that up in the unit circle. So 5 pi over 6 is here. Now cosine is the x, so negative root 3 over 2 is the cosine of 5 pi over 6. Okay. And I don't necessarily need you to write this in your work if you start to just memorize that secant means flip the fraction. I'm just being very explicit so you understand my steps here. So that's the reciprocal of that, so I get negative 2 over square root 3. Notice it's looking very familiar because it's also a multiple of 30 degrees. And then you get negative 2 root 3 over 3 again. Okay, so make sure you rationalize. That's all there is to it. So we're just practicing looking these up on our reference. Let's talk about tangent. We'll talk about tangent, and then we'll talk about some no solutions undefined problems. Okay, find the exact value of tangent of 7 pi over 4. So I'm going to look it up, 7 pi over 4, and that's almost 2 pi if you think about it, right? So I know that's going to be down here somewhere. Okay. Now we're kind of stuck, right? So I know cosine is x, sine is y, but there's no tangent on here, and there's no other numbers. So there's one fact you need to know. The fact is tangent of an angle is equal to sine of an angle divided by cosine of an angle. And that's a geometric fact, and you can, if you play around with triangles, you might be able to see why this is true. So set up a triangle, take its sine divided by cosine, and see what it starts to look like. So we're going to use that fact. So in this case, we have root 2 over 2, and negative root 2 over 2 is sine. Okay, so tangent of 7 pi over 4 is negative root 2 over 2 over root 2 over 2. Okay, now you have to divide fractions, so I could think like, okay, dividing fractions means I flip the bottom one and then I multiply straight across top and bottom. Or in this case, I could note that they're the same number and just say that the result is 1, and then we have a negative. So negative 1 is my tangent. Okay, so that's pretty cool, right? That's a useful fact given that we have this reference that only gives us sine, cosine. Similarly, if I had cotangent is the reciprocal of tangent. So the same fact could be written as cotangent of theta equals cosine theta over sine theta. Okay, so we just take the reciprocal. It still works. We can still find it the same way pretty much. Okay, let's talk about these boundary angles real quick. So what I mean by boundary angles is multiples of pi and multiples of pi over 2. Okay, and they're called boundary angles because if we look at our unit circle, pi falls on the x-axis, right? So we have negative 1 and 0 are cosine and sine. The reason that this is true is because this is a 180 degree angle. It's a multiple of 90 degree angle. And you can't have two 90 degree angles in a right triangle, right? So these angles behave a little bit differently. We want cosecant of this guy, which is 1 over sine. Okay, so we're going to take 0. We want sine. And you maybe see where this is going already. So cosecant is 1 over sine of pi, which is 1 over 0. So we say this is undefined or no solution. I think undefined is the word that Delta Math uses. So that is a possibility as well when you're dealing with these, what are called boundary angles. The last thing I'll say on this lesson is as you're working through this, the Delta Math examples solve these in a more challenging way that I'm giving you right now. So make sure you're using the unit circle as a reference. Again, either copy it down in your notes or have it pulled up in a separate tab. And it'll make your life a lot easier. If you need more examples, let me know or come back and rewatch the video.